Welcome grade 11s. Today we are going to be looking at some important concepts that you need to be successful even at grade 12 level, and that is number patterns, sequences and series. So in grade 11 you are introduced to the important new concept called quadratic sequences, and some learners get a little bit confused about how to work out the general term of a quadratic sequence. I promise we will look at that a little bit later on. But we're going to start off by looking at the terminology and just reminding you what things mean. All right, so some of the special terms. A sequence or a pattern is an ordered set of numbers or variables. Now, a sequence of numbers doesn't need to follow an ordered pattern. It doesn't need to have a general term attached to it. A sequence can just be an arbitrary list of numbers. So any list of numbers that doesn't necessarily have a pattern. Once it's got a pattern attached to it, or once it has a general term that we can attach to it, we can then go on to find terms in the sequence based on the general term. So successive or consecutive, you will see us use this often. Successive or consecutive basically means terms or anything that follows directly one after the other in a sequence. A common difference when we're dealing with a linear pattern, we see that the first difference will always be a common constant difference. So a common or constant difference is the difference between any two consecutive terms in a linear sequence. The general term is a mathematical expression that describes the sequence. It generates any term in the pattern by substituting different values of n. So in other words, you can use that general term Tn to find the value of any term. You can also use the general term Tn to find the position of any value in a sequence. All right, so if you know what the term is, you can find out where it's situated in that sequence. Let's start off with linear sequences. So remember that a sequence of numbers in which there is a common difference between the terms is called a linear sequence. So say, for example, we've got the numbers 45, 29, 13, and 3. All right? So to work out if there is a common difference between the numbers, I'm going to say term 3 minus term 2. So term 3 will be this one. The little number tells me the position of the term 2 and term 1. Term 1, we also call that A. It's the first term in any sequence. So term 3 minus term 2 and term 2 minus term 1 should be constant. They should have the same value if this sequence is in fact a linear sequence. So let's test it. We've got 13 minus 29, which is, let's have a look, I think it's negative 16. We can double check that. So 13 minus 29 is negative 16. What's also important, guys, is we've got to say term 3 minus term 2. You cannot say term 2 minus term 3. You would get the wrong sign for the common difference if there is one. All right. Similarly, you'll say term 2 minus term 1, not term 1 minus term 2. So term 2 is 29 and term 1 is 45. And 29 minus 45, you can double check, is also equal to negative 16. So therefore, this sequence is in fact a linear sequence with a common difference of negative 16. So to find the next three terms, I simply add negative 16 each time. So negative 3 plus negative 16 will give me negative 19. And then negative 19 plus negative 16 is going to be negative 35. And in fact, let's just double check those values and make sure we're saying the correct thing. So negative 16, and where we're at, minus 19 will give me negative 35 as the next term in the sequence. And then negative 35 plus negative 30 and plus negative 16 will give me negative 51. So those are the next three terms in this linear sequence. All right. We are asked to now find the general formula for the following sequence and then find term 20. So the first thing you need to test is the sequence in fact linear? How do we do that? We say term 3 minus term 2 and then term 2 minus term 1. If those values are the same, then we have a constant difference and therefore the sequence is linear. So 19 minus 16 will give me a value of 3, and then 16 minus 13 also gives me 3. So therefore we have a linear sequence with a common difference of 3. How are we going to find term 20? Well, in order to find term 20, we need to find the general formula, because remember, the general formula will help you to find any term in the sequence. How do we do that? Well, what you need to do is you need to obviously first determine the common difference, which was 3. Then what we do is we identify the relationship between the value of a number and the position of the number. So we look at Tn in that sequence and we look at n and see what the relationship is. So this is what I'm saying. In position 1, so the term in position 1 had a value of 13, the term in position 2 had a value of 16, the term in position 3 had a value of 19, and so on. So we've got to determine now what is the formula for this linear sequence. So what we're going to do is we start with the value of the first term, and we're going to try and write an expression for it that includes the common difference d, and it must also include the position of the term. So in other words, it needs to include n. So I can say, well, term 1 is equal to 13, we know that. How can I rewrite 13? Well, 13 is the same as saying 13 plus 0 times the common difference. 0 can be rewritten as 1 minus 1. And then we say, obviously, it's times by your common difference of 3. Why am I doing this? Why am I just saying 1 minus 1? Where am I making all of this stuff up? Remember, what we're trying to do is we're trying to get to a general term. We're trying to get a formula. So we need to examine this pattern. We need to make the formula ourselves by looking at the position of the term, looking at the value of the term, and seeing how we can relate the two. So I'm almost making something where there isn't anything. And what we can do once we understand this method, though, is we can apply it to all of the linear patterns that we will come across. All right? So therefore, I can rewrite 13 as 13 plus 1 minus 1 times 3. And hopefully it will start making sense as you look at term 2. We're going to now write a similar expression for the second term, which is 16. 16 is 13 plus 1 times 3. So there's my common difference. And if I times that by 1, I'm going to end up with 3. 3 plus 13 will give me 16. I can rewrite 1 as the term position, which is 2, right? Minus 1. So 2 minus 1 times 3 will still give me the same value as 1 times 3, of course. So we'll start noticing this pattern that's forming, and as you go through to the next one, you'll see the same thing. So for the next one example, if we look at 19, 19 is equal to 19 plus, it's in position 3, so it's plus 3 minus 1 times, sorry, not 19, this should be 13. So it's 13 plus 3 minus 1 times 3. 3 minus 1 is 2, 2 times 3 is 6, 6 plus 13 is 19. And if you go on to the fourth term, you will get the same thing happening. You're relating the first term in the sequence, you're using the position, and we are working out this general term. All right, so we can see the pattern that's formed is Tn, the general term is the first term of the sequence, plus n minus 1 times 3. If I simplify that by timesing the 3 into the bracket, I get 3n minus 3, 13 minus 3 is 10. So therefore the general term is 10 plus 3n. And then we were asked to find term 20. So all we'll do is we replace n in our general term with 20. So our general term was 10 plus 3n. So therefore 3 times 20 is 60. 60 plus 10 is 70. Okay guys, at this point, let's take a quick break. When we come back, we're going to move on to quadratic sequences.